Okay, so this is the base exponential formula. And if I give you a starting value of 400, and we'll say it's boulevards, okay? Then if after 3 years, it's worth 200, then the question is, what's K? Notice this wasn't a 1-year half-life question. This was, it became worth half, but over the course of 3 years. So it's not quite as simple as the currency gets to be worth half every year, and it isn't that simple in the real world either. Actually, things can change even within 1 year. You might have really high inflation now, and then it might slow down a few months later, and then it could go really fast again 6 months later. Yes? Good question. I do not need you to put this in a calculator. I just want you to be able to solve this with a log. I'm assuming you'll have a log in your answer. And you don't need to actually find me a decimal of 1.243 or whatever. All right, you should have put a start value of 400. And I'm using a 2 here. Do you get that that base does not have to be a 2? It could be an E, which is 2.718. It could be a 5. It could be a 1/5, but we started with 2. It could be starting with anything. And the K I don't know, but the T I know. The time is 3 years, so I put a 3 there. And then how much it was after 3 years is 200. And then I solve it, and you will get K, and you will not be done. Once you find K, then the question is, write me an equation that can find me the value of my money after any amount of time. In other words, it's an equation like this, except you know how much you start with, but you don't know how long it's going to be before you want to turn them in. In the real world, with what we just read on the story from the internet there about how they're replacing the paper bills within 72 hours. That's quick. So just a few days from now, it'll be worth 0. Granted, they're trading them for coins, but I'm not saying it's a bad plan, honestly. I don't know what the ramifications are of it, but I would be a little nervous about having to carry around giant bags of coins in Venezuela. If they don't have paper money, I would think the coins would weigh more. And wouldn't you think a coin would weigh more than a bill? Like a fair amount more? Yeah, you'd think you could put paper's a little flatter. I don't know. Anyway, okay, so here's what you should have gotten. First of all, divide by 400. And that worked out really nice. I did that on purpose so that it would work out nice. And this comes out to 200 over 400 is 1/2 equals 2 to the k times 3. Then I would rewrite ln log base, oh, actually, no, log base 2, not ln. Log base 2 of 1/2 equals k times 3. And then you would get the 3 off of there by going 1/3. There. That's k. Raise your hand if you got the same k as I did. Did anybody simplify it more than I did? Ooh, what did you do? Oh, okay, wait. Did anybody simplify it more than I did? I'll get back to your question in a moment. Yes?
You can get negative 1/3.
Okay, how did you get that? Because this part here became...
You can make the 1/2 on top 2 to the -1.
This is 2 to the -1. Genius.
Equal to -1.
Yes. So if that's all -1, then -1 times 1/3 is -1/3. Holy cow. Very nice. Good job. Okay, now were you going to ask something?
Would ask if it was acceptable that if you did log base 2 of 1/2, all of that over 3.
Oh, yes, except that we just found out that it simplifies. And you are expected to simplify it all the way down. So now that we know it simplifies down to -1/3, his question was really just, instead of having 1/3 in front, could you have divided by 3? Yeah, but it means the same thing. And all said and done, it simplifies to -1/3. Okay, so your final answer was write an equation. So that has start, an end, and 2 to the k, but we know k this time, -1/3 t. Do you get what I just did there? Except we also know the start value. The start value will never change. Start value is 400, wasn't it? Now, what's good about this equation? It can figure out any value for my money. If I have 400 bolivars and I want to find out what it's really worth, I got to know the time. And the time here, let's say I make it 7 years, well, then it would not work out real nice because I picked a bad number. How about if I pick 12 years? Would you please figure out what the bolivars are worth in 12 years? We've done all kinds of real world problems. This one I tried to make it the value of a currency going down. This would be end equals 400 times what is 2 to the -4th 1/16th. And basically that means your money's worth 1/16th of what it used to be. Do you get that? That happens to also work out nice because then 400 divided by 16 both has a 4 in it, and so it could be final answer (100/4), which is 25. Notice no calculator needed. All I did was change my 16 into 4 times 4 and my 400 into 4 times 100. Then I could cancel the 4s. 100 divided by 4 is 25. So at the end, the bolivars you had are now only worth 25 of them. And so that's one of the reasons deflation really stinks. If you have any money, you wait and it won't be worth anything very long. Yes? If you don't simplify all the way, you will get it wrong. Here's another one. Let's try another simplify. This involves a whole bunch of log rules. Okay, like this 2. Well, how about this? If I do this, it'll be overly simple. What's the answer? 10. Because you know that the bases are the same. You can just jump right to that's the answer. Okay, so we wouldn't do that. That would be a little too easy. But what if we said 2 to the power of 8 to the power of log base 8 of 3 to the power of 2 times log base 2 of 4. Now, when you're done, your answer could either be something like 2 to the 54th power, or there's a much more creative way to write it. I'm not saying that's the answer, but I get it's going to be a really big number, 2 to a really big number. But there's a really fun way you could write it so that it would be using really small numbers that elementary students would even understand. First, try to get it as just 2 to a big number, like 2 to the 54th or something. I'll pause for a second while you give that a try. Okay. let's get a little bit of this done. How many of you actually got it all the way simplified down? All right. Actually, I'm going to check a few of you before I jump into the answer. So I'm going to pause this. I owe you food for reminding me to record again. Okay, so this 2 squared, this 2 needs to go up as a power on that. And so that becomes 2 to the 2 times 2, so that's 2 to the 4th. So once I have that and that being the same, that's to the power of 4. This turns out to just be equal to 4. Okay, because these two are the same, that's the answer, but that has to have that power on it. That's why it's 4. So then this is really 3 to the 4th. And then if these are the same, then this thing equals all that. So 3 to the 4th. So it's 2 to the 3 to the 4th. And then one kid added something unique at the beginning. What do you think? Just stretch a little bit. It's even a stretch. 1 times 2 to the 3 to the 4th. There we go. Okay. So that's what that big, nasty, hairy log thing simplifies down to. So that was just one of many patterns in logs. What are some other patterns you know about the logs? Like if certain things are this way, then it turns out that way. Remind me of some patterns. All right, so if you've won the argument, then this will equal 0. How about now? But you said if the 1 was the argument, then it automatically was 0. Ah, but the base can't be negative. Can the base, what else? How about this? What if I said the base is x? Then I could say, what is the domain of this function? Write it in interval notation. That'll test a couple things if you remember what domains are, and if you remember how to write things in interval notation, and if you remember what the restrictions are for a base. Don't show me. I'm going to pause for a second while you give this a try. Okay, I'm going to do it with a number line. Do you get that x can't be negative and it can't be 0? So you probably have those like this and then maybe like that. That's wrong. What else can't it be? The base cannot be 1, and therefore I have to have another empty spot here at 1. And now if I wanted to write an interval notation, it's 0 to 1, union with 1 to infinity. And it can't be 0 and it can't be 1. Maybe you've forgotten that the base can't be 1. Here's an example of why. Do you get this means 1 to the x equals 3? And that's impossible. Because you can't put any power on a 1 to make it grow. 1 to the 500th is still just 1. Yes? I get what you're saying. You can create something that will make the base work, and that's the only thing. But because only one thing ever works out of all the possibilities, it's kind of like a reverse domain. Instead of everything works except 1, nothing works except where there's a 1 in the argument. So they just rule it out as a possibility. You're just not allowed to have a 1 in the base ever, even if you can force it to work by putting a certain argument there. All right, so next up, you haven't seen this in a while. Real world problem involving snakes. Now, in the Slytherin clan, they have 40 members initially. It grows to 4,000 over the course of 4 years. A lot of 4s going on. The question is, assuming a natural log was used, in other words, a base of e, then what's k? I'll say the numbers one more time. Had 40 members, grows to 4,000 over 4 years. what's k? And the last question is, if there's 40 right now, how many will there be next year? A lot more than 40, but nowhere near 4,000, right? I'll say that one more time. 40 members turns into 4,000 members over 4 years. Figure out K and then figure out for me how many members will there be next year. I'll pause while you try that. Okay, so 4D, turns into 4,000 over the course of e to the k times 4 years. I hope you solved that and then got 4,000 over 40. Zeros cancel. 4s turn into, well, those cancel, I guess you could say, and turn into 1 and 1. And then it's 100 equals e to the 4k. Then I rewrite ln log base e of 100 is equal to 4k, and then get the 4 off of there, 1/4. There we go. Who got the k right? Okay, good. So then I'm going to rewrite my equation. It's going to be my start, which was 40. They always had 40 to start with. That's not going to just change all of a sudden. And then my e to the k, now I know, is this 1/4 ln 100. And then I times that by t, and that will give me my ending value, how many they have. But I told you one more piece of information. I told you that next year, which implies time of what? 1. How many members would they have? Well, then there's only one thing left. That's the end. I can find the end by doing all that. So that would require a calculator because I didn't give you nice enough numbers to be able to just simplify this puppy down. Can you? How? What are you doing up here? Oh, I see. You're bringing the ln 100 to the 1/4. And then you could say it's log base e of the 4th root of 100. All right, I can buy that. This is e. Oh, that's even better. You're right. E, and that's got a base of e. And then you're right. So that's 40 times 100 to the 1/4 power. Very good. A lot further simplified than I thought it would. Yes? Couldn't t be 5? I said next year. Oh, you're assuming. Yeah, but that's not okay. That's a good clarifying question, and if I was ever to write this on a test, I'd need to clarify that. I only wanted it to be how many there were there. I should have said it this way. How many were there in their second year? That would have been a better way to say it. Okay. So, so many log problems, so little time. Any other pattern type questions that you want to ask me, or actually anything that you've been tested on in the so far, like by homework or by, we had a little formative test that you guys took. Any of those topics that you want me to do another one like? Yes. All right. There are 6 main things. One is a rewrite. So let's try it the other way than normal. Rewrite that and tell me the answer. I hope this is like, oh, it's easy. Should be. So what is the rewrite in question here? 2 to the 5th equals x, and therefore x equals 32. Very good. Okay, now I want you to do the same exact problem, except use one of my other strategies, which is not rewrite. It's make a constant into a log. That 5 can be times by something to make it into a log. Why would I do that? Because then you'll have log on both sides, and then you can pull the logs out, and you'll have your answer. Do you get if I times this by log base 2 of 2? I really have only times it by 1, and yet I've made it so there's logs on both sides. Before I so rudely yank these logs out of both sides, I've got to do something with something. What has to happen first before I can do that? 5 has to go up as a power on this 2. Now I can take the logs out, blink, blink, and it's x equals 2 to the 5th. You might say, why didn't you just do a rewrite? It's just another option. Okay. How about make the bases the same? Is this one of those kind of questions? Not really, but this would be. Don't solve it all the way. Just get it so the bases are the same. Making the bases the same is one of the big 6. I'm willing to do more, but you'd have to tell me. I've done make the bases the same. I've done rewrite. What's another one of the big 6 that I should do after this? Yes, ma'am? Oh, a U substitution. Yes. I like it. I'll do that next. So this is 3 to the x equals, how could that be a 3? If it was 3 to the negative, because that'll make it flip into a fraction. Negative what? 3 to the what is 27. Do you get how that turns into 1/27th? Because 3 to the third is 27. And then the negative makes it 1/27. And then that's all to the power of 3x minus 1. Why did we do that? So we made the bases the same. So that has to equal all that. And you'd have to distribute it out. It's going to be, it's a fair amount of work from here, but it's all algebra, so it should be easy. Next one is that U substitution was suggested to me. So I'm going to say e to the 2x plus 3 e to the x equals 4. Do a U substitution and solve. I'll pause for a second while you give that a shot. So I'm just going to work quietly. You guys ignore me until you're done, but I got to try to catch up because you're way ahead. So we let U equal e to the x. That is an important step. If you didn't say it, you don't have permission to just change it to u squared plus 3u minus 4 equals 0. Notice I brought that to the other side. Then u plus 4, u, terrible u, try again, u minus 1, u equals negative 4, u equals 1. And if you ever say u equals at the end of the problem, you have a problem because u is a substitution problem and I haven't substituted back that e to the x is really what that is. E to the x equals negative 4 and e to the x equals 1. Can I just stop right there because at least I remembered that? No, when can I stop? X is alone and they have to be simplified. So I have to do a rewrite. ln, or base e, negative 4 equals x, that's alone. And ln of 1 equals x, and that's alone. But I said alone and simplified. As you start simplifying the one on the left, who all caught that that's not possible? Raise your hand if you did. Awesome. And then this one, you won the argument. What do you get? X equals 0. Okay. That's U substitution. At one point earlier in the hour, we changed a constant into a log. That was one of them. Condensing and expanding logs. But usually when you're solving, you don't want to expand it. You want to condense it. Do you remember the rule? If you have 2 logs, you have to mush them together. Combine them, make 1 log. All right. So now, this is the part where you've asked a lot of good questions, and I will answer questions all the way to the end of the hour. And you're going to have to start thinking of, well, what am I going to do to study for tonight? And I encourage you to go back, look at past assignments. To be completely honest, something you did 5 days ago, if you just look at the problem the blank problem, like download a new one from the website, you probably don't remember how doing them. So like you could probably do over anything from 5 days ago and you might not even remember it. You know what I mean? If it's last night's homework, the stuff we did over the weekend, yeah, you'd remember that. So it'd be kind of hard to do that one over again. But I always skip one or two. Go back and do the ones we skipped. Look at website, my website, servervideo.com, where you find this video and other videos before it. Get together with friends. I see kids get together at Caribou sometimes and just like say, hey, let's go study for that test together. And then you go over and do some problems together. It makes it more fun. And especially if you're not a master of the stuff, maybe the other kids can help you with it. All right, so the test is tomorrow. Last thought, I want to talk about the lab. So that lab is not due tomorrow. It was technically due today, but I sent you an update over the weekend that said I'm officially putting it off to Wednesday. So if in the perfect world you had 50 M&Ms in your cup at the beginning and you rolled them, at the end you'd have 25 of them up. Do you get how the perfect world isn't always perfect though? But imagine just for a moment that you just had that. And we used a base of 2 to the kt solve for k. Everybody do it right now. It's a good practice problem. And this was essentially your lab, except it's only one of them. And this one worked out perfect. Got to get the clump alone here by dividing by 50. Oh, I know T though. What was T? I only did one roll, right? Or one time? Or one, what was I using for that? Trial, yeah. And so there's K. But that can be simplified even more. Because 1/2 is really 2 to the what? And therefore K's got to equal what? That'd be if it was in the perfect world. Was your world perfect? Did when you rolled the M&Ms, did they always come up exactly half? Well, I'll give you an example. Now we have 25 M&Ms, 12 minutes left. And with our 25 M&Ms, how's that going to go in exactly half? You know what I'm saying? It's an example of where it can't always be 1 or -1 or whatever it is. All right, so that's one way of solving it. Did you get to the lab ask you for find another way to solve it? Well, you're allowed to use a calculator. And what I just did there, I never even needed a calculator for. But there's another way that you would need a calculator for. Yes, sir. Yes, sir. That's a good question. Each person has to do their own lab. All you did is gather data together. I don't want smart kid to go do the lab and, hey, it counts for all 4 of us. Nope. You got to do it yourself. You can work with other kids. Yes, sir. You have to know those formulas, yes. So we can tell you the formulas if we want to, but we want you to know the formulas. Now, the only one I would say that we would not expect out of you is that we'd have to tell you the ones for investment because we just learned them on Friday. Amount equals P times E to the RT. That's PERT. That one's not too bad. The other one, much more complicated, and we'd have to give it to you. So. But this general formula that we keep using over and over again, where this is start and that's end, and this is a base that they usually will give us, and this is KT, you have to know that formula. Okay, so that's a little bit of help with the lab and what we're expecting on that. And that is due on Wednesday then. So when you're done with the test, your only homework for that night will be to finish up that lab. Yes? That's a good point. This is a lot like PERT, where this is P and this is like E, except we used an E for a base instead of a 2. That's all. And this is an R instead of a K. But yes, otherwise it's pretty much PERT. Good point. All right. That's all I got for the video for today.